Hello everyone, welcome to Fantastic Solution. So today we'll be solving a Leetcode medium problem named as number of ice length. So let's go through the problem and see how we can solve it. It says given m cross n 2D binary grid. So we are given a grid as input, and which represents map. One is basically land and zero is water. So wherever you see this one, this is land and zero is basically water in this grid. Our goal is to return the number of island, here. So what is the total number of island, which we have inside this grid? Now, what is the definition of island? It says island is surrounded by water and is formed by connecting adjacent lands. So whatever the adjacent land we have, we can connect them. That would be an island. And we can go and connect the island, the land horizontally or vertically. So any ones which we have, we can go in horizontal direction or vertical direction. And it also says you may assume all four edges of the grid are surrounded by water. So like outside, if you're going to the grid, then that is a water for us. That's the assumption which we need to take care of that. So let's say for this one, the output is 1. How is it coming 1? Let us go and try to see this. So here, if you see it's starting with 1. So these are the adjacent cells. This is again adjacent. So this is like one land, or one island which we can form where we can see each one is adjacent to each other, right? So let's say if I'm starting from here and I can reach all the one by one. So let's say from here I can go down, down, and I can connect them. From if I'm here, I can go here, up, up, right? Or to come here, I could have come from here as well. From here, I can go one right, horizontal, then again right, and then down. So we know that everything is connected here. That's why this is one island and there is no other one still remaining. So here, that's why our output is 1. Here we have the output 3. Let us see how is it. So this is one connected island. If we try to go outside of this, here we have 0, here again 0, 0, 0, right? This is diagonal, so we need to go horizontal and vertical only. For this one, this is again one thing, one island where we have the length only one, right? Only one, like only one of the one is 1, like one of the node is 1, right? And for here, we have 2 length of, where we have the length of land is 2. So that's why the total number of island is 1, 2, and 3. So one thing to note that the moment we see somewhere 1, we know that we have found one island. Only thing to know, like, what is the total, like, what are all the, the ones which is directly connected with that. So we cannot directly just go ahead and count, the total number of ones here and return it, because the total number of 1 is not, the number of island. So the total number of connected ones are going to return only 1. So the moment we found somewhere 1, so we know that the minimum, number of island is 1, but how many ones are again, connected with this particular one, that we'll also need to know. And for all the connected one, the total sum of the island will be 1 only. That's the only goal. So let's say if you're starting from here, we know that we have got one island the moment we found the 1, but now we just need to go and iterate in all the horizontal and vertical direction and find all the connected components. And these all connected component will return a single one to us, right? Because that will be one island only. Here we only got the length of the island was only 1. So we just return because there was no other connection. So again, like for this one, we return 1. For this one, there was no connection, but since we got a 1, we know that at least this is again an island. So we got 1. From here, the length was 2, right? So we again got a 1. So that's how, this will work to know the island and all. So how can we solve this? So now mostly it looks clear, right? So we need to just start from the grid from the start, and the moment we found any island like 1, just need to go through the DFS function or any function which you are writing DFS or VFS, and find all the connected components, and from all the connected components just find all the connected components and return only 1. Like the count of the island should return only 1. And if you again encounter somewhere again 1 in the future, then again call the same your DFS or VFS function, which is going to go and which will go and find all the connected components in all the direction and return you the 1. So at any given point, let's say if we found an island, we need to go and explore all the direction and see if any of the connected components have, again the one or not. That's the end goal for us. So hope this is clear. Let's see one more example how we can do that. So from here, let's say we have written some DFS function, right? I can just this one, yeah. So let's say we have written some DFS function which takes care of, let's say, some index, like at which particular node we are there. And just assume, let's say this DFS function is going to return the one based on, by going through all the connected components, and then it will go and return us one, the count of one. Like it will tell us whether if we tell that, hey, we found for this particular INJ cell, or return how many connected components we have, like, and just go through that and then return one. So that is one of the function. This is, which is going to return one or true, based on the number of island. So the moment we got a one, we'll just pass this, the location of the I comma j for this particular cell. And then what's the internally this function should do? Let's just assume it should go and explore in all the directions, right? All the four directions. So these are basically out of this grid, right? So we don't need to explore that, but we can go right and left, right and down. So the down, since we already have the zero, we can ignore that. Right, again we went there, right? And again we got a one. So again we can call our the same function, which will again go and explore in all the directions, right? Here, since it's out of the boundary, we can ignore that. And since this one, we can just ignore this because, we are just coming from this place only. So from where we have come this, again, we need to, ignore this. So here we need to ignore this. So just keep in mind, every time you find one, call your, the same function, which is going to return you one or not, right? For the number of island or not. And it's going to explore, in all the direction. That should be the goal of this particular function. And if you're going outside the boundary, it should ignore it. And again, if you're going to the same place, from where you have come, it should also ignore that. And from here, let's go and move into the right direction again, right? So from again, we will call the same function, which what will do, it will go ahead and explore in all the directions. So all the directions will go and see whether we do have one or not. So here again, it's a boundary condition. So we can ignore that. This is again from where we are coming. So again, we need to ignore that. So and here we got a zero, then it will return a false. We again got a one, then this is good. This will again go, and explore in all the direction. That's the end goal of the function. If we got the one, then explore in all the direction. That should be our goal. If we get zero, then return false and go, outside of the boundary. Then again return false. Don't need to go outside the boundary. And then the fourth one is, coming from the same place, right? If you're going to the same place where we came, right? So same cell again. If you're going, then just go or return false, something like this. So these four things, if we can take care of that, then our function, it will return us the exact, the island total number. Like it will tell us how many like our island we have it or not. So that should be our end goal of the function. And let's try to write it down, then it will be more clear to us. For so can we write, let's say if the one of the edge case condition we can write, if grid is equals to null, then we don't need to explore it at all. Or even if the grid dot length is zero, right? Then just return the zero because total number of island would be zero. Now let's go ahead and explore the island now. So let I equals to zero. I should be less than grid dot length. I plus plus. So let j equals to zero. J should be less than grid of I dot length. J plus plus. And then let's create a variable which is going to keep the track of all the number of island. So let number of island initialize with 0. And anytime if we find the grid of I comma j, right, that if grid of I is equals to 1, then we know that we have found an island, and we just need to increase this variable by +1. So if we know that grid of I is equals to 1, then we know that number of island is going to increase by 1. And at the same place, if we find at any place 1, we have to call our DFS function, right? So let's call our DFS function, which is just going to take this I comma j, and just hope that this will, what it will go and explore all the the connected components and return us this single one as an output. So our assumption is we are going to write some function which is just going to explore all the island, the connected components for this island, and then return only one, because if we got a one, then we are going to add only one here. That should be our end code. And then once this function is complete, then just go ahead and return this number of island, right? So for each one which we are going to find, right, the unconnected component, right, then we are going to return one. So in this case, what we will be doing, our assumption is this loop will run at one time, and for this particular component, this will return one. So we'll be adding one here. For this one, this will return again a one. Then we'll be adding one as two. Then for this one, this will return again, one, and it will return three. That's our end goal to write this particular DFS function. Should be. Now let's quickly go and write the function as well. Which takes this indices, like which current cell we are there. So one thing what we are going to do when we are returning the false, right? The false we are returning if we are going outside the boundary, or if it's a 0, or we are going outside the boundary, or we are coming from the same cell, right? So let's say if you're going outside the boundary, if I is less than 0, or I is greater than equals to grid dot length, or j is less than 0, or j is greater than grid of I dot length, right? So this one boundary condition we just wrote, that anytime we are going outside this particular boundary, right, then we don't need to explore this. That's the very first condition which we explored. And then the second would be if it's a 0, the value is currently 0, right? So we again don't need to return 1. Or if grid of I comma j equals to 0, then again go ahead and return from here, the count should be something 0, right? We don't need to return 1 here. So these two we are done. Just to mark it like this, we are good, and this very good. Now we need to take care of this same cell, and what if you're going to get 1? So if you just look into this properly, what we know till this place, now if it's not, the grid is either it can be 0 or 1. So now if you're going outside this if block, then we know for sure that this is a 1. So at the very first time you're coming here, and either we are not going outside the boundary, or if it's not a 0, then for sure this particular cell is a 1. So the moment we are going here out, outside of this if block, then we know that this particular condition is nothing but a 1, which is satisfying for this one, right? For the very first time. The moment we know that this is 1, then again we need to explore in all the direction. That means call the same function again. So let's just do this same thing. So explore in all the directions. So I plus 1 comma j, and I minus 1 comma j, then DFS of I comma j plus 1, and j minus 1. And once we are done with like all the exploration in all the direction, right, and we know that we haven't found either 0, or if we found again a 1, then again go ahead and explore in all the direction. Then at the end of the day we need to return 1, right? So once we are done with all our function, just go ahead and return 1, right? Because this will return 1 for entire island. So we are done with these three conditions now. What about this condition, whether the current cell is same cell or not, right? That we need to take care of before exploring in all direction, right? So from here, if you know that this is already a 1, then I need to go and explore in all the direction, right? So for the very first time, how the function will work, right? It will just go and check whether I'm going outside the boundary or not. So this will come here. This is not neither outside the boundary and nor 0. So that means it's 1. Then I need to go ahead and explore in all the direction, which I will do using calling the same function, right? Just increasing the indices of the cell. And then I'll be here. Then how do I know that the previous cell, I just don't need to go and check or do something, right? So one thing which we can do, we can just go ahead and change the same variable without one. So either we can change with some other character, which we can add the condition here in this particular place, let's say, or grid of I comma j equals to some other character which we are going to replace, right? So that means before going into the next direction, right, just go ahead and mark this grid of I comma j with some other character, right, equal to, let's say, something hash or something, right? So here we can just put the same hash, right? That then we know that if we are replacing with the hash, then we know that here we don't have to go, right? We have came from this particular cell only. Or we can also keep 0, right? Because we don't need to extra condition. We know that this is a 0, then just go ahead and update with 0 as well. That doesn't make anything like, it doesn't go ahead and increase the complexity. It will be exactly same. We just care about the 1 only, right? So even if you replace the 0 in future, we don't have to go back and traverse from there, right? So that should be fine. So this will take care of the same cell condition as well. And now just go ahead and let's try to run this. Output is 0. What's been happening here? So we are saying j is less than I is greater, I is equals to 0, and I is less than grid of length, right? Here it should be less than j equals to 0, j should be less than grid of I dot length. And if we find at any grid 1, then we just go ahead and explore this DFS, and this is going to return 1, right? Because we know that at least we got a 1, so we are going to add only 1 here. Here what we are doing, if your I is less than 0 or greater than grid dot length, or j is greater than equal to grid of I dot length, or even if it's a 0, then return 0. Then we are just going to make the same character 0 again and explore in all the direction. Yeah, now let's go ahead and run it. Cool. Now let's just go ahead and submit. Yep, so this got accepted. So that's it about today.